The Earth is an extremely complex, uniquely programmed planet, and all living cells are in a delicate state of existence. The smallest degree of change could cause significant effects on us and our surroundings. The distance between the Earth and the Sun, the levels of oxygen and nitrogen in the air, the angle and speed of the Earth's rotation, gravitational force, atmospheric pressure, and the list goes on. If any of these parameters were to change, even slightly, Earth would not be the planet we know today. We're living on the most unique and robust planet in the entire universe. In fact, the more we research, the more we discover just how much of a razor's edge we're really on. Hi, I'm Chris. Join me as we explore the programming of life on planet Earth. Humans. We're an interesting specimen, incredibly intelligent, insightful, advanced species with an unquenchable thirst for knowledge. A thirst that continually drives us for answers to the unknown, like where did mass and energy originate? Or where did we come from? Although science has no answers to these mysteries, we can look around us and observe our surroundings in order to better understand ourselves and our extraordinary planet. All matter is made up of chemical elements, like the ones on this periodic table. Chemical elements are a pure chemical substance made up of one type of atom, and the nucleus of that atom is made up of two types of nucleons, protons and neutrons. These nucleons are held together by what is called the nuclear force. This force is what binds all protons and neutrons into atomic nuclei. The nuclear force is a complex program that brilliant minds around the world are still trying to understand. Elements are the building blocks of all matter and are distinguished by their atomic number, which is the same as the number of protons they have in their nucleus. For instance, the nucleus of an atom of oxygen has 8 protons, while the nucleus of an atom of carbon contains only 6 protons. If we chemically bond one atom of carbon with 2 atoms of oxygen, we get the molecular formula CO2, which of course is carbon dioxide. The bonding of molecular elements is very important when considering the programming of life. Each bond is determined by a chemical program prescribing exactly how the elements will bond and how strong the molecular bond will be.
The chemical bonds are programmed by the electron shells that they share electrons, and that determines the distance between the atoms, it determines the bonding angles, it determines how they fit together, which ultimately determines the chemical bonds.
There are 4 main elements that all life is composed of: hydrogen, oxygen, nitrogen, and carbon. Hydrogen makes up about 59% of the atoms of life and is the most prevalent component of life. Hydrogen not only forms bonds with carbon, creating hydrocarbons, but it also combines with oxygen to form the compound most critical to life, water. When scientists examined the element hydrogen, they found that it would not exist if its strong nuclear force were larger. And if that force were smaller, hydrogen would be the only element in the universe. The nuclear force constant has been shown to be an extremely finely tuned parameter upon which all living organisms depend. Oxygen makes up 24% of a cell's atoms and is critical for metabolism in most life. Multicellular life typically transports oxygen by the use of hemoglobin in the blood. If the heme-oxygen bonds were stronger, cells would not be able to access the oxygen, and if the bonds were weaker, the lungs would not be able to oxygenate the blood. As you can see, there are many parameters in life that, if altered even slightly, would destroy its very existence. Nitrogen, at 4%, is another incredible element of life. It's a major component of proteins and genes, and although nitrogen makes up about 80% of the atmosphere in the form of molecular N2, that form cannot easily be absorbed by living cells. Most plants and animals rely on nitrogen fixation organisms to break down the nitrogen into a usable form. This process can also occur naturally through lightning. When lightning surges through the air, it splits nitrogen atoms, which then fertilizes the vegetation below. Once again, too much or too little nitrogen would significantly affect all life on Earth. The probability of having the right amount of nitrogen in the atmosphere has been calculated to be 1 in 1,000. Carbon makes up 11% of life's atoms and also has many qualities that make it uniquely suitable to be a major component of life. It forms bonds with many other elements to produce the chemicals necessary for life, including those of the information-holding structures like DNA and RNA. These bonds are strong enough to withstand harmful chemical and physical assaults, yet weak enough to allow many different kinds of reactions, especially those enabled by enzymes. Another interesting aspect of carbon compounds is that they're found in all three states: gas, liquid, and solids. One of these gases that we all depend on is carbon dioxide. The probability of having the right amount of carbon dioxide in the atmosphere has also been calculated to be 1 in 1,000. If the concentration were higher, it would result in a runaway greenhouse effect, and if it were less, photosynthesis wouldn't be able to produce the necessary oxygen levels to support life. If we were to combine the probabilities for the requirements of both carbon dioxide and nitrogen in the atmosphere, the result would be a probability of 1 in a million for just these two chemicals. Clearly, we live on one exceptional planet. There's an extremely common and critical chemical substance that's so essential to life that some consider it to be a programmed masterpiece, and you probably take it for granted every day. H2O, or water, is essential to all plants, animals, and living organisms, and it appears in nature in all three common states of matter. It's found as vapor in the air's humidity, seawater in the oceans, icebergs in the polar oceans, glaciers and rivers in the mountains, snowflakes in the midwinter air, and in aquifers surging under the ground. H2O is a universal solvent which carries nearly all other compounds needed by life, and it has many unique properties which are critical to the existence of life. For example, ice is less dense than water, so when bodies of water freeze, they freeze from the top down rather than from the bottom up like most other liquids. Once it becomes solid, ice becomes an insulator, protecting the liquid below from extreme weather conditions. Now, this may not seem important to you, but to aquatic life in colder environments, it's a matter of life and death. Water also has a high heat of vaporization, which allows animals to regulate their body temperatures through sweat glands, or in the case of dogs, panting. Due to water's high surface tension, it permits capillary action in vascular plant life, allowing water to move against the force of gravity, distributing vital nutrients from the base all the way to the top of the plant. Water also plays important roles in climate control and the formation of geological structures through glacial action and freeze-thaw cycles. Another interesting attribute of water is its boiling point. According to the boiling point trends of other hydrogen-containing compounds, H2O should boil at minus 148 degrees Fahrenheit or minus 100 degrees Celsius, but as we all know, water actually boils at 212 degrees Fahrenheit or 100 degrees Celsius. The reason for this anomaly is the strong hydrogen bonds between molecules, which is created by the angle of the bond itself, making it completely distinctive among its liquid peers. So how does such an incredible compound get produced in the first place? Well, there are many chemical reactions that produce water, but one reaction that occurs in all life is during the joining of two amino acids. When two amino acids are joined during the creation of proteins, the byproduct of each reaction is one molecule of water. It's pretty amazing when you think about it. Each property of water, freeze-thaw points, high vaporization, high surface tension, its boiling point, and its strong hydrogen bonds are all programs working flawlessly to make water so incredibly unique.
Water is so important that when you found evidence that there might have been water on Mars, for example, the instant conclusion was, well, there must be life then, because if you have water, you must have life. Water is that important that people will instantly jump to the conclusion that if there's water, there has to be life. But there's a vast difference between water and life.
A scientific law is a phenomenon of nature that's been proven to consistently occur whenever certain conditions are met. In 1665, Isaac Newton was able to theorize about gravity's effect and eventually discovered the mathematical relationship which led him to this equation, describing the force attracting two masses separated by the distance between them. This mathematical equation is our current understanding of the program that controls gravity. And just like the law of gravity, the laws of motion, chemistry, quantum mechanics, radiation, photonics, electromagnetism, thermodynamics, and all laws of nature are incredibly fine-tuned prescriptive programs which have been in place since the Earth's beginning. Although we can approximate a law based on our observed understanding of it, there's an underlying formal law that controls its physical attributes through prescriptive information. Now, even if we don't understand the fundamental mechanics of a law, we can simulate a law's effects using computers. For instance, when a programmer is creating a virtual reality video game, algorithmic programs are created which simulate gravity, light, wind, rain, and other natural artifacts.
As a 3D animator, I rely heavily on a tool set that is based on some fairly complex algorithms that help simulate lighting, gravity, wind, fluid dynamics, things of that nature. In order for me to be able to attain that imagery, it would be virtually impossible to do that without the complex programming that underlies the tool set.
All life requires countless unique programs to control and direct its processes. Our mathematical expressions of a law are based on our best understanding of how it works. And if we obtain new information which changes our understanding of how the law works, well, then our expression of that law can change. In the early 1900s, Albert Einstein's theory of relativity changed many equations that had stood true for centuries. There used to be separate laws for the conservation of mass and the conservation of energy, which said that neither matter nor energy could be created or destroyed, but could be converted from one form to another. For example, if we were to burn a piece of wood, the mass of the combustion products, water, CO2, and carbon, is the same as that of the reactants, oxygen and cellulose. The potential energy stored in the wood is exactly compensated by the heat and light energy released. The theory of relativity combined those two laws into the law of conservation of mass and energy and revolutionized our understanding of time, space, and gravity forever. Think about this. A nuclear power plant can produce 2,700 megawatt hours of electric power per gram of nuclear mass converted to energy. That means if you could convert the mass of one can of soda into energy, it would produce enough electricity to power 1 million homes in the United States for an entire year. So, understanding the enormous amount of mass and energy that exists on our planet and in our universe, while also understanding that matter and energy cannot be created or destroyed, leaves scientists perplexed on its origin. Some have proposed scenarios such as an oscillating universe that has always existed, alternating between a big bang and a big crunch. And yet other scientists have speculated the existence of dark matter, which can't be seen, but whose mass would make a collapse possible. The second law of thermodynamics says that in a closed system, like our universe that has conserved mass and energy, disorganization always increases. Biochemist Isaac Asimov felt the same way when he stated, "As far as we know, all changes are in the direction of increasing entropy, of increasing disorder, of increasing randomness, of running down." Yet the universe was once in a position from which it could run down for trillions of years. How did it get into that position?
So the fine-tuning of the universe is a big problem for strict naturalism. And the reason is because there's no way that that type of universe could arise by chance. Let me give you an illustration. NASA was able to send a man to the moon and bring him back. But that would never, ever happen without engineers, without countless calculations, because there was only one way for them to make it work, and there were a million ways for it to go wrong. And so it's like that. It's like saying, well, could man go to the moon and back again by chance? No, it takes intelligence to make incredibly improbable things happen.
An infinitely old universe that is not at maximum entropy violates the second law of thermodynamics. So, what's the chance that the chemical elements of life formed by undirected natural process, or that the physical constants required by science for life to exist formed by undirected natural processes? Well, the materialistic scenarios proposed so far have been deemed operationally impossible. The challenge that today's scientists wrestle with is how to explain the fine-tuning that's been scientifically verified in nature. We understand that there will always be philosophical and theological debates when trying to answer these kinds of questions. But if we take a stance based solely on our beliefs, then this would take us outside the realm of science. It's important to realize that empirical science does not depend on knowing the purpose or the mechanisms of the law. For example, the law of gravity has been observed to be extremely accurate for determining intersections of moving objects in three-dimensional space, helping us to achieve our incredible quest of landing a rover on Mars. Science does not yet fully know how gravity works, and we may never understand why it works. But what we do know is that it consistently works, every time.
The process of critical thinking is essential if we are to develop what we feel is a true understanding of our Earth and our universe. If we don't use critical thinking and we go with our biases and simply our beliefs, then we will not really develop a correct picture of our universe and not really understand what our universe is all about.
People interpret data differently, largely based on presuppositions and training. Currently, those adhering to the undirected natural process scenarios are in control of the vast majority of the scientific community. So those holding any other view are, for the most part, shunned as being unscientific. And yet, chemical evolution is still taught as fact in public school systems, despite its lack of scientific evidence and, in some cases, deceitful practice. In the late 1800s, biologist Ernst Haeckel had a theory that human embryos had gill slits, which he believed was proof of evolution. By the early 1900s, his drawings had been disproven and exposed as fraudulent. However, up until 1960, all textbooks used Haeckel's theory to support Darwinism. And sadly, some textbooks still use Haeckel's example today. And there are other examples, like Nebraska Man, the Stanley Miller-Urey experiment, 96% chimp to human DNA similarities, junk DNA, and others, which have been shown to be false, but are still consistently being used to support Darwinism. How can we, as a scientific community, allow this kind of deceptive information to continually poison our classrooms? Can we really expect our students to grow and flourish under these misrepresentations of science?
If we teach students information that is incorrect without qualifying it in some manner, then the student is going to develop an unclear understanding of how the scientific process works. In the long run, that will undermine science, and eventually people will not trust scientific discovery.
Other theories on life's origin have been proposed, like the abiogenesis argument, which implements a multitude of assumptions, simply stating that the initial spark of life just happened. The probability of life, a simple cell evolving by undirected natural process, is 1 in 10 to the 340 millionth power and has been shown to be operationally impossible. Abiogenesis assumes that meaningful prescriptive information can be created from a purely physical mechanism, which completely violates the laws of information.
The formation of life from non-life, called abiogenesis, has been studied for many, many years, and there's different scenarios that have been proposed and speculated as perhaps life arose by one process or another. But all of the scenarios proposed are science as we don't know it, because they're trying to speculate on what happened previously, and there is nothing that even comes close to formation of life.
Biological philosopher Ronald Brady wrote, "By making our explanation into the definition of the condition to be explained, we express not scientific hypothesis, but belief. We are so convinced that our explanation is true that we no longer see any need to distinguish it from the situation we were trying to explain." Dogmatic endeavors of this kind must eventually leave the realm of science. With these scenarios becoming more and more common, science must provide a rational theoretical mechanism, empirical support, prediction fulfillment, or some combination of these three to truly be taught as scientific. Anything less is simply teaching philosophy. Long-held models of origin by most theistic religions typically involve an infinite energy being, converting energy to mass or otherwise supernaturally creating the mass and energy of the universe. These models, like the other origin models, cannot be tested or falsified by known science. Other models will undoubtedly arise, and as they do, each will need careful examination to verify any scientific validity. Paul Davies, a professor of theoretical physics, wrote, "The really amazing thing is not that life on Earth is balanced on a knife edge, but that the entire universe is balanced on a knife edge, and would be total chaos if any of the natural constants were off even slightly. Even if you dismiss man as a chance happening, the fact remains that the universe seems unreasonably suited to the existence of life." In 2009, astrophysicist Dr. Hugh Ross prepared a list of 501 parameters that any planet or comparable site within the universe would have to possess in order to support bacterial life for 90 days or less. This list was based on a study of more than 650 research papers, which were published in astronomical and astrophysical literature. From this list, Dr. Ross formulated the probability of any single planet in the universe meeting these 501 parameters. Here are some of his summarized findings. The probability for a planet to have just the right amount of atmospheric oxygen, carbon dioxide, and nitrogen to support the simplest life is 1 in a billion. If the gravitational force were altered by 1 part in 10 to the 39th power, our sun would not exist as it does now, causing the Earth to be uninhabitable. If our solar system didn't have large planets like Jupiter and Neptune to accumulate space debris, the Earth would be struck by so much debris that life could not survive. And these are just a few of Dr. Ross's findings. The probability of all 501 parameters being met in a single planet is a mind-blowing 1 in 10 to the 311th power. That's a 1 followed by 311 zeros. Here's an example to help explain what this means. Here we have the state of South Carolina. If we were to take South Carolina and cover it 2 inches deep in 1-cent copper pennies, and a single 1943 copper penny was blindly tossed and mixed into the entire state filled with pennies, the probability of choosing that 1943 coin on the first try would be 1 part in 10 to the 14th power. That's 1 chance in 100 trillion. That's pretty small. Now, what if we covered the entire 48 contiguous United States 2 inches deep in copper pennies, from coast to coast, and a single 1943 coin was blindly tossed and mixed into that pile? The probability of then choosing that coin on the first try would be 1 in 10 to the 16th power. That's 1 chance in 10,000 trillion. If we repeated this experiment with coins covering the United States and continually picked out that 1943 copper cent on the first try 19 times in a row, the probability would be 1 in 10 to the 304th power. Now that's unbelievably small, but even that chance is still 10 million times more likely than our original 1 in 10 to the 311th power. Starting to get the idea? Keep in mind, scientists generally consider anything with a probability of less than 1 part in 10 to the 70th power to be operationally impossible.
We humans cannot even begin to comprehend how incredibly small 1 part in 10 to the 311th power is. There are only 10 to the 80th atoms in the entire universe. So it really has nothing that we can objectively compare it to. It's so small.
No matter what your belief, be it evolution, creation, or alien inception, it's up to the scientific community to find the empirical evidence needed to support these theories. To pretend that a scientific sounding scenario is actually science does a disservice to both the scientific community and the public, and diminishes the reputation of all science by anyone examining the evidence. Does science support adaptation within a species? Absolutely. But we never see random mutations creating the new genetic information required for a new major group. We do see population fragmentation, meaning there can be many varieties within a related grouping, but we never see new information. For example, a canine-type fragmentation would include a wolf, a fox, and a dog. We can also observe further fragmentation within those types, as you can see here with these dogs. So science does support population fragmentation, but not evolution. In fact, mutations have never been observed to produce a net increase in functional information. So we must ask the question, why are our classrooms so biased towards evolution? When evolution is taught, its scope should be limited to what is known, eliminating unwarranted speculation. Evolution has been a knowledge stopper for decades. For example, how much time and resources were spent studying the vestigial organs, only to discover that all 180, which were considered useless remnants of evolution, are actually useful and even vital. For years, the concept of the selfish gene was popularized by the well-known evolutionist Richard Dawkins, continually touting that 98% of the human genome was junk DNA, whose only purpose was to serve as raw material for producing useful mutations for Darwinian evolution. In 2012, the published ENCODE research represents a milestone for education and the academic world. After 9 years of coordinated research by many teams of scholars, the ENCODE Consortium published their major findings in 30 open access papers. The consortium has remarkably found that 80% of the genome contains elements linked to biochemical functions, destroying the widely held belief that the human genome is mostly junk DNA. And it seems likely that soon we'll have a better understanding of the entire genome. Had we not adhered to evolutionary thought, we'd have understood DNA for what it is, an incredibly complex and beautiful language within the cell whose programming directs all aspects of operation. Had we not been under the belief that junk DNA existed, where might science have led us today? DNA and RNA are computer programs that continue to astound us, not just in living organisms, but in their ancestors as well. The fossil record is a historical record of the programming of life on the Earth. Preserved deep within the rock layers, we find millions of organisms which all started from a single cell, but through the genius of real computer programs, DNA and RNA, they have developed into incredible organisms. The probability of forming the simplest single-cell life without taking into consideration the programming within the cell has been estimated as 1 part in 10 to the 340 millionth power. That number is far beyond anything to which we can relate, since there are only an estimated 10 to the 80th atoms in the entire universe. The probability of forming a multicellular organism by chance processes is truly incalculable, and the formation of millions of species, each with a multitude of differentiated cells, is truly incomprehensible. In the mid-1800s, there was a discovery made in the fossil record known as the Cambrian explosion. The Cambrian explosion was an abrupt, rapid appearance of most major phyla, displaying a major diversification of fully formed organisms in that era, an era which makes up less than 0.1% of the history of life on Earth. In his book, The Blind Watchmaker, Richard Dawkins says it is as though they were just planted there without any evolutionary history. Chinese paleontologist J.Y. Chen, who lectures around the world, stated recent fossil finds in China are inconsistent with the Darwinian theory of evolution. And British paleontologist Bud Graham said the expected Darwinian pattern of deep fossil history stretching millions of years into the Precambrian has singularly failed to materialize. Through millions of drilling and excavation sites, building projects, and scientific endeavors which have taken place all over the world, we have uncovered billions of exceptionally preserved organisms, and after careful investigation, few have ever been shown to be a transitional fossil, though millions should be present. Paleontologist and evolutionary biologist Henry G. noted that to take a line of fossils and claim that they represent a lineage is not a scientific hypothesis that can be tested, but an assertion that carries the same validity as a bedtime story, amusing, perhaps even instructive, but not scientific. The Cambrian explosion shows us that there was a point in time when there was a sudden increase of fully formed, highly programmed organisms with no prior evidence of evolution or transitional fossils. With a century of intensive collecting behind us, we now know these exceptionally preserved biotas occur globally. So how did such an abrupt explosion occur in the Cambrian fossil record with no prior evidence of evolving fossils? Since the release of Darwin's book On the Origin of Species, published in 1859, our scientific techniques, technology, and discoveries have advanced by leaps and bounds, showing us that Darwin was wrong on his ideas of the origin of species. Natural selection cannot explain the existence of millions of living organisms, each of which contain millions of unique computer programs controlling the information of life. Scientists, students, and critical thinkers alike are examining and questioning how such exquisite programming could arise by chance processes.
If we base our science on false ideas and things that are not shown to be true, then we basically are building science on philosophy and not on evidence. And we need to get back to where we go where the evidence leads.
Following Chen's announcement of his Cambrian fossil research, German biologist Dieter Wallacek declared while rallying his Western colleagues around him, "It doesn't matter if you find it or not. It's there. It's by law. All of the major taxa should have been there in the Precambrian, whether proved or not." The idea of valuing a theory over data is unscientific, and because this is not an isolated incident, it's giving Western science a bad name.
A person isn't free to employ critical thinking until they hear both sides of an argument or until they hear the different perspectives on an issue. If a person is only informed about one point of view, they obviously can only accept that point of view. If they're shown several points of view, then they can employ critical thinking and they are greatly empowered to make decisions for themselves of what they believe and what they think is right and what they think is wrong. So we understand this generally in the educational system, but on certain controversial topics, this is rejected and people say, no, we're going to indoctrinate, not do education. And that's catastrophic because basically we're denying the students the right to hear both sides and to choose. And that's just fundamentally wrong. It's just unethical.
When alternatives to naturalism are explored, we can experience a well-rounded education and adhere only to the empirical evidence which has been proven. Theories should be repetitively tested using scientific methods until they fail. And if a theory is continually tested and does not fail, then and only then does that theory become viable. Evolution has fallen short in the areas of geology, biology, astronomy, and most recently, information science, and yet we continue to hang on to this broken theory. If something can't be proven feasible through scientific principles, it should not be considered science. Understanding this incredibly simple concept will allow us to recognize what is science and what is philosophy. If we truly want to make scientific progress, we need to put aside our biased beliefs and work together to examine and discover our future. Thanks for joining me and opening your minds to the world of critical thinking and the programming of life. I look forward to the future of science and where it may lead us. Until next time.